A 200 kilogram box is on a horizontal frictionless surface. All right, so everything that we've been doing with friction, we don't have to worry about with this question. (200 kilograms). 200 kilogram box on a frictionless surface. A force is applied to the right at 65 newtons. So we're pushing it to the right. 65 newtons. A force is applied to the left at 48.22 newtons. Letter A asks us which direction is the box moving. But let me ask you an even easier question. Which value of force applied is larger? Is it 65 or is it 48? Yeah, very simple. 65 is larger than 48.22. Because of this, and we know that 65 is pressing in the right direction, which direction is the box moving? There's no friction, nothing else is happening. We have 65 going this way, 48 going that way. Which direction is the box moving? You're right. The box, to answer letter A, is moving to the right. Because we have a larger force applying to the box going to the right direction. Next, it's asking us, how far does the box move in 6.34 seconds? Okay, this is a little trickier, but this actually is something that you guys have already been doing for the last 2-3 weeks now. How far does the box move in 6.34 seconds? So, tell me, what is the equation for Newton's second law? Bingo. Newton's second law tells us that force is equal to mass times acceleration. Our force is equal to mass times acceleration. If this equation rings true, and it does, then we can figure out the acceleration of this box, knowing the force, and we know its mass. If we figure out the acceleration, we can definitely figure out how far it moves in a certain time period. So let's figure out first the amount of force this box is actually experiencing. So if we have two opposite forces acting on the box, one is larger than the other, we just subtract the smaller value from the larger value. So I'm going to erase letter A here, and let's subtract 48.22 from 65. We get 16.78 newtons. Great. So this is the net force that the box is feeling. So we have 16.78 is equal to our mass, which we already know. Our mass is different than the weight. So what is the mass of the box? That's right. 200 kilograms. And we're looking for its acceleration. We don't know that yet. Let's figure this out. How do we find the acceleration? Well, we would say our A is equal to 16.78 divided by 200. What does that give us? Our A is equal to 0.084 meters per second squared. Very slow acceleration. It's not moving very fast. That makes sense though. If we're only applying 16 newtons of force to a box that weighs 200 kilograms, which is, almost like 500 pounds, it's not going to be moving fast, is it? So we have that acceleration. What's an equation that we've been using for the entirety of this class that deals with final position, some acceleration, and some form of time? Yes, you're right. Our cheat code equation, our xf is equal to 1/2 our acceleration, which we found right here, 0.084, times the time, which is given to us in the question, 6.34 seconds. That is squared. So that's squared. Let me ask you this question. Why is this acceleration not 9.8? You're right, because we're moving in the horizontal. We're not moving up and down. So we don't have to worry about gravity in this question right here. So let's solve this right now. So what I'm going to do, I'm going to do 6.34 squared. I'm going to multiply that by 0.084. And I'm going to multiply that by 0.5. And we get a final distance of 1.69 meters. There you go.